Get going.
I don't have a pen, so I might write on that.
I don't know. Look in the box. I gotta have something in there. What? No?
Or even buy a rubber rat.
Thank you.
Mm-hmm.
Like,
Walmart.
actually.
Yeah. The same aisle as the remote control cars. They always have a bunch of like the cheapo toys. The same aisle as the remote control cars. They always have cheapo toys and like, yeah, on the other side of that aisle. All right, now. You quiet, you do math. There you go. Get those conversion charts out. Who we missing? Got that one, that one, that one, that one. Oh. That one. Right? Yeah. That one, that one, that one. That one, that one. That one, that one. Let's see, that kid, that kid. That kid's gone. That one's here, that one's here, that one's here, that one's here. Probably. In the very back, yellow side tab, reference section. This is so horribly wrong.
My brain isn't working today.
That's still wrong. That's 3.5. That's why. That's a whole tile off. And a whole tile the wrong direction. 1, 2, 3. Okay, we're going to go to the right, and ahead. Right there. There we go. I don't want to know what you know on his paper. That's like not the point of this. You tell me. Yo, daily quiz. This is your gut check moment. Gut check moment is for you to do the thing with your notes and your book and your materials, just like you would on a test. So you can tell yourself, yes, I understand this. Or no, I don't, and I need to ask more questions. I'll move you up here, Abby. There we go. I do not want to know what your neighbor knows. Getting the right answer on this by doing something your neighbor told you to do, or that you copied down, or just ignoring the problem entirely and writing down what I write after the fact, does nothing for you. Then you get to the quiz and wonder why all of your 5 out of 5s and 4 out of 5s got you a 60. Okay. Oh, did you? I'm going to tell you to write your answer as both a fraction, if it comes out that way, and the decimal equivalent, or decimal approximation. Write your answer as both. If it comes out as a fraction, write the fraction. Then put the decimal approximation next to it. Okay.
This one, is it okay if I put the repeating thing over that, or do you want me to?
Ew. Well, you got the fraction next to it.
I can just like.
And then do the decimal approximation. I'd take it. Fingers in your eye.
My contact.
Oh, go in the bathroom and fix it.
No, it's okay.
Okay, looks like most of you are done. I'm going to give you the last few who are working a minute. We there? We there or admit defeat? Okay. What do I know right now? So I start with that. 25 miles to 1 hour. I'm going to need to multiply this in order to switch it over to feet per second. So, well, hurry up. You got my next blabbing to figure that out. Do I have anything that goes directly from feet to miles? Yeah, I do. So I'm going to multiply that by... There's 5,280 feet in a mile. But what goes where? Okay. 1 mile, because if I were to now throw this all over one fraction, that 1 mile is down here. I'll have miles over miles canceled, just like anything, any factor over itself cancels. So I've got 1 mile on denominator and 5,280 feet. I'm going to show miles and miles cancels. I'm now in feet per hour. I don't want to be in feet per hour. I want to be in feet per second. So it depends on your jam. If you've done enough of these problems already now that you just know there's 3,600 seconds in an hour, go for it. Okay? If you don't, then you need a shortstop of, in 1 hour there are what? 60 minutes. And I say hours cancels with hours. I'm now in feet per minute. I don't want to be in feet per minute. I want to be in feet per second. So I'm going to keep going and say that in 1 minute there are 60 seconds. And again, yo. God, I keep forgetting crap. Okay. I keep forgetting the thing. Nope, not them. Nope, not them. Nope, not them. Where is them? Do you know where them is? Not you. Not you, not you, not you, not you. It was just here. That was terrible. And that's where. Thank you very much. Okay. Multiply all the way across top. Multiply all the way across bottom. I will have 25 times 5280 over 60 times 60. Okay. Grab your calculator and tell me, well, first of all, fraction style. Right? Okay, 110 over 3. So I'd say it's 110 over 3. What was it, feet per second? Yeah, feet per second. But then I also want to turn that into 36.66666, so 667 feet per second. Okay. Said, and the decimal equivalent. Because if I say something, I don't know, maybe I'm talking about what the muzzle velocity is going to be on my auto nailer. Nail gun. If I say it's 10 thirds or 110 thirds feet per second, most guys who are running an auto nailer, maybe they're doing a roofing crew, are going to look at me and say, huh? So instead, if I tell them it's about 37, oh, okay. Then that'll make more sense. So, did you have the right conversion factor? Did you have the right conversion factor and the right conversion factor? If you were one of the ones who said 3,600 seconds to an hour, who's got that? Who was the handful that did that? Okay. If you did that, yay for you. Cool. Did you have the correct answers? And then I'm going to leave a 1 floating for making sure that you put everything in the right spot. That you were actually crossing out your units. Okay? Yo.
Is it okay if we converted the hours to seconds before we converted the
Oh, yeah. Multiplication's commutative, right? So if I were to rearrange that whole thing and do this stuff before that stuff, that's fine. Yeah. That's the nice thing about them is you get your choice. Anything else? Okie dokie. You go away. Yes, save that. You go away. You get big. You thing. First, talk to me about the homework. There were a handful of you who came in and got some help. Worked on some stuff. We had time in class to work last time. Remember, it was just the front side of that worksheet. Maybe make a note to yourself. Next time we do a quiz, you're going to hand that worksheet in, same as your packet of notes, same as your daily quizzes and assignments anywhere else. If you did them in a separate sheet of paper, because honestly, there ain't enough room there unless you write real tiny. Just make sure that it's labeled. Say just like 2-6 worksheet. Fine, good enough. Is there? No, that's not a question. That's just that's a squiggle. Okay. All right. Anything? A problem that stumped us on either one? Okay, so tell me what the thing is, because I don't want to fight with it.
worksheet?
24 on worksheet or in book?
On the worksheet.
Okay. Hey, there we go, worksheet. 62 inches over to meters. Okay. So, y'all got that conversion chart. I think you've gotten fairly familiar with it. Who do what? Yeah, use it. It's a book. It's where we used to keep the knowledges. If I need to go from inches over to meters, there is nothing that will do that right now. Can I go from inches over to something else in metric? What? Centimeters? Inches to centimeters. How many? Okay. It is approximately, right? So we got to know that when we get to our final answer, it's almost this. So I'm going to take my 62 inches over 1 times, if I want to get out of inches, I need inches on the denominator, like this. I show that my inches cancels with my inches. Now I'm at centimeters. I don't want to be in centimeters. I want to be in meters. That one should be more familiar. Centa is a prefix that means 100. That's why we have dollars and cents. That's why every 100 years is a century. Okay? So I'm going to take this times 100 centimeters to 1 meter. And we'll say centimeters and centimeters cancel out. So across the top, you've got this times this, 62 times 2.54. On the bottom, I've got 100. Jam it in your calculator, get her done. And whatever its approximation is. Were y'all doing okay with reading that chart? Like, off to the side, it shows you length, area, volume, liquid, mass, temperature, and then there's a whole separate section for converting customary over to metric, or vice versa. Okay? There's whole sections for it telling you where to go and what to look at. And after your time in physical science, I would say by now you've got to at least recognize what is standard and what is metric. So, mores. Cool. Then, argue. Figure it out. I'm going to say, he's the one who can just like, get your, you think having a bad contact, like wait until he takes your eyeball out. Okay. Puzzle it out, grab a calculator, guess and check some numbers, try some equation stuff, whatever you're going to do. How many of each type of bead?
What? That's what it's asking.
How many of each color bead will you need to make the 20-inch necklace?
So,
Here,
you said
if they're specifically talking about colors, you got to remember that blue is red and red is blue. There you go.
Maybe if you could read small beads. Small little ones. You can't read? That's what I'm saying.
Hmm. Yes.
It's pretty confusing.
Yes.
Very much so.
That's a statement. So, what total do I know? 20 inches. Okay. So maybe I should find out how many sets of beads I need to make that length. How'd you get 16? 20 inches divided by 1¼ inches tells me how many of these sets of beads I need. Okay, so do 20 divided by 1¼ or 20 divided by 1.25 or 20 divided by 5/4. All same thing. I get 16 sets of beads. What's in a set of beads? 3 blue, 2 red. So if I have 16 of those sets, can you now tell me how many of each? They're saying I have 16 of those. So what's 16 times 2 reds? 2? Oh, 32 red. What's 16 times 3 blues? 48 blues. Okay. Take 20 inches divided by 1¼ or 5/4 or 1.25. Yes. That'll tell you how many of these sets of 2 red, 3 blue. Then I just multiply by whatever that scale factor was. There's something called proportional reasoning. It's kind of a big word. Okay, yeah. Proportional reasoning is something that I'm really a big fan of because it's amazing to watch people's differences with proportional reasoning. What if I tried a different one? What if I tried something where you don't have to convert? Like, all right, y'all fresh meat. Who went to the homecoming dance?
I did. It was fun. You guys should have came.
Oh, I'm surprised. Normally, that's the one that's full of freshmen because it's the first one freshmen are allowed to, and that's why the upperclassmen don't go. So what if I said for every 2 guys on the dance floor, there are 5 gals. The guys and gals. Okay. What if I were to then say there are 84 kids on the dance floor? How many of each? Figure it out. For every 2 guys in the gym getting their groove on, there's 5 girls. How many of each?
Are you sure it's gonna work out?
Yes.
Count it out.
Couldn't you just like multiply it by numbers until you get the right one?
That's one way to do it.
What do you mean? It's just
Come on now. For every 2 of these, there's 5 of those. There's 84 altogether. Here.
Seven times
alright.
That's the game struck. That's 12 sets of people.
Oh my gosh.
stop.
Where's all the, imagine me being the smart guy here.
I
crazy.
Okay. I've heard a couple of you overheard a couple of you. And you got the right idea. One group of kids is 2 guys, 5 gals, 7 kids. So, how many groups of 7 kids go into 84? 12, right? 84 divided by 7, 12. So that means if there's 12 groups, then there's 12 of these and 12 of those. Okay? This is called a proportion. A proportion is when I can take a ratio of this thing to this thing, and I can set it equal to this thing compared to this thing. What I would do here is I'd say there's 2 guys for every 7 kids. How many guys will there be for 84 kids? I compare the same thing to the same thing. Guys to total. Guys to total. As long as I'm comparing the same thing, the ratio should still hold true. If I took this thing times 12, then to keep it balanced, I better multiply that thing by 12. Okay? Proportional reasoning is something that some of you might be able to just look at it and think, well, divide by this, multiply by that, duh. But you would never be able to turn it into this, into an equation. Okay? I actually wrote a whole thesis on proportional reasoning in students. The way that I set it up is fraction equals fraction. It's thing A compared to thing B has to equal, how about thang A to thang B? In terms of word problems. Okay? Y'all know what I mean. Is it a thing or is it a thang? Okay. And if I compare those, now I have to know, suppose that looked more like thong, not thang. And then we start getting into some weird conversations. If I have 7 over 8 is m over 12, what does this mean? What does that do? M over 12. Divided. So how do I undo that? Multiply. Okay, so I'll multiply by 12. 12 over what? Right? I can turn anything into a fraction by putting it over 1. So here, cancel, m over 1 is just m. Y'all remember cross-canceling? We've talked about it enough. Hopefully you remember it from middle school. The idea is when I multiply straight across, I'm going to have 12 times 7 over 1 times 8. Could I just call that 12 times 7 over 8 times 1? Which means if I know that 12 and 8 both have a 4 in common, I know 12 over 8 is 3 over 2. I can reduce it. So if I can reduce it by moving things around, how about we cut out the middleman and just say 12 divided by 4 is 3, 8 divided by 4 is 2. You cut out the middleman and just cross-cancel. Where this gets sketchy is there's a difference between cross-canceling and cross-multiplying. And we're going to be doing that today. Okay? So, now I multiply straight across and say 3 by 7 is 21, 2 by 1 is 2. M is 21 halves. Now, it ain't pretty. It is possible that you end up with a compound fraction. Compound fraction is a fraction within a fraction. Y'all seen Inception? Movie's like 10 years old now. It's where they go into each other's dreams. Okay? And then they go into the dream here, but within the dream, they also go into their dreams. Within the dream here, they go into their dreams. And they go so many levels deep, and then eventually one of them goes nuts. Okay? Inception. It's a good movie. It'll break your brain, but it's a good movie. Here's what I mean by this is Inception. This is a fraction within a fraction. Is if m is 21 halves, then technically I write this as that. M is 21 halves, right? It's a compound fraction. Compound fraction means a fraction that has a fraction in it. Dividing by fractions as easy as pi. So if I take 21 halves times 1/12, cancel out a 3, getting 7/8. You have to be able to work with fractions. This is all stuff that we learned back in elementary and middle school. Or should have. I want you to walk down to the middle school and tell your math teachers you never learned about compound fractions. And watch them just straight up.
We never had a fraction on a fraction.
No, I never did. I never did. Well, yes, you did, but they told us.
Then they horribly failed you.
Yep.
So, go. If that is x over 7, what do I do to undo that? Multiply. Now your answer might be a fraction itself. That's okay. Just make sure that it's reduced. You'll be fine.
Why can't you make it regular decimal?
Is it a terminating decimal?
Yeah.
Okay, I'll accept it.
Why you gotta make it so complicated?
Because teachers that allow kids to just work in decimals and round things off and say, well, close enough, those kids come up to geometry and algebra 2 and they're forced to do things the real way and they crap their huggies. Because their algebra half and algebra 1 teachers let them get away with something they shouldn't have. I see the aftermath. I see the when you get to algebra 2, if you go up to pre-calc. I see the kids who come up that far and weren't forced to do it the right way. And it hurts. It's painful trying to unlearn 3 years of doing it the wrong way. Because there's some math you just can't do if you don't do it this way. Now, it doesn't have to be absolutely bonkers. Just multiply like that, right? Now, if all I have is 28/5, that's fine. If you want to call that 5.6, 5.6 is 5 and 6/10, or 5 and 3/5, or 28/5. They're all the same thing. Okay? They're all the same thing.
What happened to the 4?
I multiplied it by 7?
Literally multiplied by 7. Oh.
I only had half a lunch. I ate it. Sorry. Okay. This is a different way to do it. It's called cross multiplying, and I think you'll like this. I don't know. I don't think we do, but I'm not going to definitively say that. Cross products. You saw this way back when. Do I want to do that? Do I want to do that? No, those were. Cross products is cross multiplying. Where I'd say, if A over B equals C over D, you know what? Actually, this. No, stop that. Why are you doing this? If I didn't want fractions anymore, what do I got to multiply both sides by? The denominators, right? If I had something over 3 and something over 4, I'd have to multiply it by 12 to get rid of both of them. I'm going to multiply this side by B and this side by B. Cancels. Cool? So I have A is BC over D. I still didn't get rid of my fractions. What still has to go away? The D. So if I multiply that by D and by D, cancels. And I get AD is BC. So instead of this, instead of multiplying in stages like that, we can do what is called cross multiplying. Pretty simple. A times D. B times C. Done. Okay? Those are called cross products. Multiplication's commutative. Don't matter. 5 equals x is the same as x equals 5. 5 times 4 is the same as 4 times 5.
ratios.
Okay, that's the note that I want you to write next to this. You can only cross multiply across an equals sign. You can only cross multiply across an equals sign. So here's what I mean. If I see 3 over 5 equals 9 over 15. I take 9 times 5 and get 45. I take 3 times 15 and get, sure enough, 45. That's how I know that these are actually equal to each other, because their cross products were the same. That's no different than times 15 times 15 times 5 times 5. Boom. I can only do that because there's an equal sign in there. If I say 3/5 times 9/15, there's not an equal sign in there. So that's when I cross cancel. Can cross cancel across multiplication sign. That's where I'm going to take 3 divided by 3 is 1, 15 divided by 3 is 5, and then say 9 over 25. And that's really tricky for kids in algebra half. I can cross cancel if they're being multiplied. I can cross multiply if they're equal to each other. Write the notes. Don't think you're just gonna remember it. Like, this is in the top 5 errors of kids making with fractions for the rest of eternity. Is they'll try to cross cancel with an equal sign, and they'll try to cross multiply with regular multiplication. Okay. In practice, it's super easy. Am I do the thing or you gonna freak out? No. Put it back. In practice, it's super easy. 4 times x is 4x. 8 times 3 is 24. Solve. Divide both sides by 4. Ta-da. That's it.
How do we go to conversions to this? Like, are we just done with conversions now?
Ratios. This is a ratio set equal to a ratio. Last time it was a ratio times a ratio. I just changed it from multiplication to equals. Okay? It's that easy. So, solve for the unknown. Both. Was it 8 and 3 or 3 and 8? That's a B. Ew. Girls. Girls just leave it everywhere. Okay. Especially on those chairs, right?
Oh, it's like static.
Don't talk about that, okay?
That little rivet on the chair, just yank.
Those little nails, yeah. You can rip your hair out.
Yep. I wouldn't know, personally. I've had the same haircut since I was 12. But you know the number of times I've seen a girl get up from her chair real fast and go, ah! Because it just yanks. Oof. Okay, we said 8 times 3 was 24. 4 times x was 4x. And then we had to divide. I'm going to do the same thing over here. I'm going to take 3 times 3, y times 5, and then I'm going to divide. I'm going to take 13 times 5, 3 times b, and divide. Unfortunately, it just stays 65 thirds. Do not call it 21.6 line. We use fractions in this house. Okay. Now here's why. For those of you who said 65 divided by 3 and you said b was about 21.67. If these are true, you should be able to use the cross products to prove it. I should now be able to say 4 over 3 equals 8 over 6. Cross multiply. I should be able to say 9/5 over 3 is 3 over 5. Or if you had chosen 1.8 over 3 equals 3 over 5. Okay. 8 by 3, 24. 4 by 6, 24. Cool. A couple of times some of you have asked me, can I write this as a decimal? And I'll say yes, because it's terminating, meaning it ends. What is 3 times 3? Y'all got a calculator. What's 1.8 times 5?
9.
It is actually 9. Okay. Y'all think we did the math right here? Said 13 times 5 was 65. 3 times b was 3b. Divided by 3. And if you said 21.67, look what happens in your calculator when you say that. Cross multiply. We know 13 by 5 is 65, but if you try to take 3 times 21.67, it ain't 65. It's close, but it's not actually that. You all know what that's like. Mom, can you pick up more Doritos? And then they come home with the Walmart version?
More like you ask for like Cool Ranch and she come back with nacho cheese.
That's a whole different flavor.
Yeah.
I'm talking about it's the exact same flavor, but that ain't right.
It gotta be the Dorito.
It's not right. That's why we have to use 65 thirds. Look what happens when I take this same equation and I swap that to 65 thirds. When I take 65 thirds times 3, I get the exact 65. That's why we use fractions. Because otherwise, you are giving up part of your answer. Now, in each of these, would you say they're fairly simple? What if I made them even easier?
I'd appreciate it.
Jesus fish.
No, they swim in. They walk on air.
Okay.
Oh, yeah. No, they swim in air, walk on water.
You notice every one of these times I had to multiply things and then divide.
What is Jesus fish? Oh, when he makes, like, he's got like 5 dishes, he makes all of them.
Alpha.
What?
Alpha.
I thought you were talking about
I
the
thought that was
The
acceleration.
fish and bread?
Okay.
Yes, I read that one the other day.
In the Christian mythology, they call Alpha and Omega, right? Beginning and end of the Greek alphabet. I am the beginning, I am the end. Alpha, Omega. Alpha, and you'll see it on the back of someone's minivan, and it's like Jesus, right? And it looks like a fish. Jesus fish. Okay? So, the reason that I call it that, A, it sticks in your head. B, watch this. Multiply the two that line up, divide by the one that doesn't.
That's definitely the Jesus fish right there.
8 times 3 is 24. 24 divided by 4 was 6. Multiply the two that line up, divide by the one that doesn't. 13 times 5 divided by 3. 65 over 3. Multiply the two that line up, divide by the one that doesn't. Now sometimes Jesus fish goes on its side. Multiply the two that line up, divide by the one that doesn't. So goldfish just went,
So the second we think we understand something,
Multiply the two that line up and divide by the one that doesn't. 3 by 3 is 9, divided by the one that doesn't. Okay? It's a shortcut to these. So, if I want to do any of these, multiply the two that line up, divide by the one that doesn't. You grab a calculator and you say 5 times 24 divided by 8. Okay? Speed run. Yeah. Multiply the two that line up, divide by the one that doesn't. Multiply the two that line up, divide by. But when you do, show the Jesus fish. Or do the cross products. Like, I don't care what you do. You multiply the two that line up and you divide by the one that doesn't. Because if you get cross products, you always multiply and then divide by the one that was with the variable. This is just a handy shortcut. They're pretty quick, aren't they?
Wait, so on tests, if we just do
Show it. Show it. Just show the fish. Yeah. Yeah? You're still showing me what you're doing. I'm showing you that, aren't I? 3 times 3 is 9. 9 divided by 18 is 1/2. 8 times 6 is 48. Divided by 4 is 12. 1 times 3 is 3. Divided by 5 is 3/5. 3 times 21 is 63. Divided by 63 is 1. 1/2 times 2 is 1. Divided by 0.1, well, what's a dollar divided by dimes? 10. Okay. If I saw that on your paper, I'd take it. Now, that's not a whole lot less work than 120 is 8p divide. Put it up here. There's a difference between I am using this to occupy my hands so my brain can think, and I'm being a giant tool. Okay? You too. How many times have I seen you him in the last half hour? Okay. Do you think, now obviously the whole Jesus fish thing, it's a visual representation of a process. Look at number 9. Isn't this still really quick and easy? Probably better than our conversions we've been doing, right? So, when it gets bigger than that, okay, I'm going to cross multiply. You multiply what's in this spot with what's on that spot. What is in the numerator of this? An entire b minus 8. An entire b plus 3. So when I cross multiply, that's 5 times b plus 3. That's 4 times b minus 8. When you cross multiply and there's more stuff up there, it just means you need to distribute. And then solve the equation like we were doing, 2 weeks ago? You disturb it. 5b plus 15. Disturb it. 4b minus 32. Then we ask Heath, who don't you like up there? Which of the 4's got to go? It's got to move. I don't like 32. Screw you. Okay. Show that zeros out. Some of you are big fans of that. I've got 5 B's plus 47 is 4B. Keep going. Who's lonely? He's lonely because he's lazy. Bring him a date. Minus 5B. Please don't. Getting 47 is negative B. I'm almost there. Just negate both sides. Times negative 1. And got B is negative 47. Now, if I did this correctly, I should be able to put that negative 47 back up here.
never mind. You know, it was a negative.
No, that's alright.
What's negative 47 minus 8? You owe your folks $47.
Borrow it.
Then you borrow another 8 for lunch. You two just stop whatever you're doing. Okay, negative 47 plus 3. You tell me. You owe someone $47. You pay him 3. If we did this correctly, our cross products should be the same. What's negative 44 by 5?
Oh my gosh.
220 in the negative.
All right, both of you just stop talking. Just stop. You're able to prove that you did it correctly by putting in whatever your solution was, and your cross products should be the same. I don't need to go to cross products. What's negative 55 divided by 5? Negative 11. Negative 44 divided by 4. Also negative 11. I'm still showing that they equal the same thing. Okay. The catch is, if you got a bunch of junk on numerator or denominator, when you do these cross products, you're going to have to distribute sometimes. Go. Check it. Always plug it back into the original. Make sure that you're getting the same thing. Hmm.
7 is second.
5 times 8, yeah.
And then is it just like that? Or
Yeah,
okay.
just like that. Cross products use parentheses, so it forces you to distribute when you need to. If I write it like that, y'all okay with it?
Yeah, that works for me. Yeah,
I guess.
why not?
What's wrong with it? Okay, it looks weird, right? Riddle me this. What's 5 times 4? What's 4 times 5? So if the order doesn't matter, what's that called?
The commutative property.
Commutative. Okay. If the order that I multiply in doesn't matter, it might help us to, instead of writing it as following the arrow, maybe I instead say 5 times 2n plus 4 like this. And I say 6 times n like that. Or maybe even just 6n. Okay, you don't need to overcomplicate things. If you understand that this times this is also that times that, do it. Distribute. Play the Who's Lonely game. Subtract 10 from both sides. And divide. Orange. There we go. You should be able to plug it back in and show that -1 equals -1. Or, by cross products, -6 equals -6. Or sorry, -30 is -30. There we go. Okay, so that's a little tougher. Not terrible, but tougher. One more. Yes, that one. We want to get a wide variety of experience, including ones with big numbers or ugly problems, because I would rather you had the practice with it now instead of when you're finally doing your homework Monday night. Because let's all be honest, that's going to happen. Some of you. If you think you have enough practice, prove it on the quiz. Okay. There you go. Yeah. You got it. Okay, don't have to be blood, sweat, and tears math, but just something as simple as, like, I'm just walking around. Natalie's over here saying, hey, now set this up right. Okay, cool. You move on with your life. That little bit of clarification can be the difference between I get this and I think I get this. Can be the difference between I think I get this and, dude, I got no freaking clue what's going on. Just that little bit of clarification. That's why we're set up like a Senate chamber in here. I want you talking to your neighbors. I want you having a discussion. That's why I want you asking me as I'm coming around. That's how we make sure that we know what we're doing. That's what I thought. We say 15 by 12. Are any of you going, instead of actually saying 15 by 12, already running for it? Saying 180? And already going for 3a minus 54? You can. You can do that. What's the risk of multiplying on the fly like that? Well, yeah, but Your eyes are crossing over a lot of numbers. You might grab the wrong number if you don't write it out. You might not see that you grabbed the wrong number. Another thing, very common, is distributing here. It is so common for a kid to write either a minus 54 or 3a minus 18. If you're not writing it out, it's very common to accidentally not distribute to both. Okay, so just be careful. Once I'm there, add 54 to both sides. Divide both sides by 3. What? Well, yeah. I learned this in 1997. Okay, I've been doing it for a while. So, last up, the word problems for these. It's important when you set the word problems. When you set them up, you have to compare the same things. If I say tall person to short person, the next one better say tall person to short person. You say, that don't make sense. Yeah, it does. Here's what I mean. Who in here is kind of tall? Oh. Heath, Ashton, right? Tyson. Okay, how tall are you?
Like 5'9", 10-ish.
5'9", 10-ish? Anyone taller? Okay. 5'10"-ish? So, y'all know how many inches that is?
It's about 120.
No. 5 feet, and each foot. Stop talking. What's a foot? How many inches? So if you're 5'10", take 5 times 12, 60, plus the other 10 inches. 70 inches.
I'm 70 and a half. You're 69.
I knew it was around 87.
Don't laugh.
What's your shoe size?
11 and a half.
Okay. So that's... Who in here is really short? Okay. We'll use Haven because I'm assuming you also use men's size shoes. So, okay. How tall are you? 5'4". It's not that bad, right? No? How many inches is that? Yes. Okay. So here's what I mean by you have to compare the same things. Now, I don't know if this is true or not. Like, your body might not be proportional to his. I mean, look at him. He's got water skis. Okay? So, you compare the same things. I can compare height to height. That means I need to do, this was Ashton's height to Haven's height. I better do Ashton's shoes to Haven's shoes. It was Ashton to Haven, Ashton to Haven. Alternatively, I could do Ashton's height to Ashton's shoes compared to Haven's height to Haven's shoes. Look at the cross products for them. 64 and 11.5, 70x. 64 and 11.5, 70x. As long as I'm comparing the same things, my proportion is still true. What I don't want to do is say Ashton's height to Haven's shoes as Haven's height to Ashton's shoes. It doesn't make sense, right? So, in the word problem, wow, this is old. Okay, a portable media player, old MP3 player. We're talking like 2001 here. Okay, like this is when iPods started coming out and you didn't have the $600 for it. You went and got the MP3 player that could fit like 3 CDs on it, and you still felt like you were cool. Portable media player, 2 gigs of storage and can hold 500 songs. Similar but larger media player, okay, now Steve Jobs is starting to take over the world, has 80 gigs of storage. How many songs can it hold? So I've got 2 gigs to 500 songs. And I also have 80 gigs. If I'm going to set up a proportion, I need to compare same thing to same thing. How do you want to start it? Because it literally does not matter. Do I want to compare gigs to gigs, storage to storage? Or do I want to do gigs to storage, gigs to storage? Or sorry, to songs. There we go, songs. 2 gigs to 500 songs. If I set it up like that, if I said 2 gigabytes is 500 songs, how do I have to write the other side? Yes. If I say this media player has 2 gigs, 500 songs, then this media player, I can't say songs then gigabytes. If I said gigs then songs, I have to say gigs then songs. Okay? Compare the same things. So anyway, wait a second. Isn't this the proportion stuff that we were doing before? Do I have to write out the rest? Jesus fish. Okay. This is more like Jesus do my math. Okay. Take the 2 that line up, 80 times 500, divide it by 2. And this is why the MP3 player that your mom bought at Kmart was the we have iPod at home. Okay. So 80 times 500, divide it by 2, 20,000?
Yes, sir.
It's quite a few songs. Same thing. Which is why, if you had a 2 gig media player, you're pretty happy back then. I don't need to get Beats by Dre. I can get on.
What?
ONN, the really lame Walmart brand.
I own a lot of things from them.
They're not terrible. They get the job done.
They kind of break faster, but that's about it.
Okay.
They're like a JD, they'll accept half the price and just not as clear.
So
Yes. You get what you pay for, but sometimes what you're paying for is just a brand name.
I didn't do it wrong.
My noise canceling headphones are $50. They work just fine. They make most of the world disappear.
You have to, what you like.
I don't need a $400 pair of Beats to do that.
Or Bose.
Oh God, no. Bose is amazing. I'm also a teacher. They pay us some peanuts and insults. I can't afford Bose. I ain't gonna borrow them. I'm gonna hawk them at the pawn shop. Okay. 8-ounce can of orange juice, 97 milligrams vitamin C. How many milligrams are in a 12-ounce can? So I should be able to say 8 ounces. Why am I talking over people? If 8 ounces compares to 97 milligrams, I should be able to say 12 ounces is to X milligrams. Multiply the two that line up, divide by the one that doesn't. What's beeping?
But the 97 is milligrams.
Yeah.
Oh, wait, yeah.
Ounces is to milligrams as ounces is to milligrams. Ashton, what is it?
145.5.
Are you sure?
Yeah. It's a terminating decimal.
Okay. I mean, it's a put up or shut up moment. You put up. So.
Yeah, so I guess our package.